All right, the next lesson in geometry is called volume of prisms, cylinders, pyramids, cones, and spheres. Okay, so it's 5 different types of figures. 1, 2, 3, 4, 5. I have 1 page on each type. Okay, the first page is on prisms. Okay, so if a prism has a volume of V cubic units and a height of H units, and each base has an area of B square units, then volume equals base times height. Okay, that's the formula. Volume equals base times height. Okay, so the bases are the sides that are congruent and parallel. We'll talk about that more later. Okay, so again, the formula is volume equals the area of the base times the height. So we'll start with one easy one. This is called a rectangular prism, okay, because the bases are the rectangles. So I'm just going to say volume equals base times height. Okay. Again, the capital B stands for the area of the base. So if the base, depends on what shape the base is. Okay. If the base is a triangle, then you use the formula for an area of a triangle. If the base is a parallelogram, then you use the formula for the area of a parallelogram. If the base is a trapezoid, then you use the formula for the area of a trapezoid. If the base is a regular hexagon, then you use the formula for the area of a regular hexagon. In this case, the base is a rectangle, so I'm just going to do 24 times 20. Put that in a bracket so you can see it better. Okay. 24 times 20. And then times the height of the prism, which is 10. And when you multiply all those numbers together, you get 4,800 centimeters cubed, because we're talking in 3 dimensions now. Okay, so you do the formula for the area of the base times whatever the height is. Okay, so that was an easy one. Now we're going to do a hard one. Example 2, what is the volume of the triangular prism? Okay, so the bases are the triangles because those are the 2 sides that are congruent. Okay, so that's the base. So you have to do the area of the triangle. Now that's a little confusing. So what I'm going to do is I'm going to draw the triangle off to the side. I'll draw it down below actually. This is the triangle. Yes, the triangle. This will be the height of the triangle. You don't know that. However, you do know it is an equilateral triangle because if you look, this is 8, this is 8, and this side right here is 8 because it's the same as this side. Okay? So each side of the triangle is 8. That means it's equilateral. That means it's equiangular. So that means each angle is going to be 60. Okay, so 60. 60. And when I draw this up here, it means each part's going to be 30. Each side is 8. Okay, so 8, 8. And this side gets split up into 4 and 4. So what is the height of that triangle? If that's 4, then the height, which is the long leg, is going to equal 4 square root of 3. Because the long leg equals a short leg times the square root of 3. Okay. So now let's go back into the volume formula. Okay. So again, volume equals base times height. The capital B, the base. The formula depends on whatever shape the base is. So in this case, it's a triangle. So I'm going to use the area of a triangle formula, which is 1/2 times the base of the triangle, which is 8, times the height of the triangle, which we just established, is 4 square root of 3. and then times the height of the entire prism, which is 10. Okay, so let's give our answer two ways. Let's give our answer as a radical, and let's give the answer as a decimal, okay? So if I want to give my answer as a radical, I will multiply everything except the radical, except the square root. So 1/2 times 8 is 4. 4 times 4 is 16. 16 times 10 is 160, square root of 3. Inches cubed. And if I gave it as a decimal, I will multiply those out, and I'll get 277.1. Inches cubed. Okay, so that's the end of the page on prisms. Now we'll move on to the next page, which is about cylinders. So here we go, volume of a cylinder. If a cylinder has a volume of V cubic units and a height of H units and radii of R, here's the formula, okay? You don't need to read all that. Volume equals base times height, okay? Same formula as the first page, but since the bases are always going to be circles, you could also think about it as pi times radius squared times height, because the base is always a circle, so it's always going to be pi times radius squared. Okay? So one intro problem on that, and then we'll get to one a little more difficult. What is the volume of the cylinder below? Write your answer in terms of pi and as a decimal to the nearest tenth. Okay? So I'm going to start by writing down volume equals base times height. I tend to always use that formula. And again, the base is always going to be a circle for a cylinder. So it's going to be pi times radius squared. So volume equals pi times radius of 3 squared times the height of 8. That's going to be 9 pi times 8, which will be 72 pi. It said to give your answer in terms of pi, and it said to give our answer as a decimal. So if you multiply that out, you get 226.2. Okay, 226.2. Centimeters cubed. Okay, so here's this next problem. Suppose the radius and the height of the cylinder below are multiplied by 2/3. Describe the effect on the volume. Okay, so I'm not going to actually get the volume of this and then multiply each by 2/3 and get the volume of that and compare the two. I'm going to try to do it a quicker way. Okay, we have a cylinder. So the volume equals base times height. And since the base is always a circle, you can replace that and you can write volume equals pi times radius squared times height. Okay. Sorry if the video seems a little slow today. I'm kind of multitasking right now. A lot to do at school today. So what we're going to do now is we're going to multiply the radius and the height both by 2/3. So watch what I'm going to do. Volume equals, the pi stays, but we're going to multiply the radius by 2/3. So check this out. 2/3 times r, I'm going to write. And that's squared because the radius is always squared. And then I'm going to do times the height. But the height is now multiplied by 2/3 also, so I'm going to do times 2/3 h. This is like a common question you might see on the SATs, a question kind of like this. Okay? I'm going slow through it, but ideally you wouldn't be able to go much faster with this question without having to do all the work. Okay? So think about it like this. What is 2/3 squared? It's 4/9. So volume equals pi times 4/9. 2/3 times 2/3 is 4/9. Then you have radius squared, and then times 2/3 h. Now you can write multiplication any way you want. So for example, like 3 times 10 is the same as 10 times 3. So let me rewrite this equation with the numbers out front. I'm going to say volume equals 4/3 times 2/3 times pi times radius squared times height. Actually, that's 4/9, not 4/3, 4/9. Let me change that really quick. Okay, so now let's continue. Let's multiply 4/9 times 2/3. Let's make that 8/27. Pi times radius squared times height. So what you want to do is you want to compare this. Put a little star. With that. So what changed? The volume gets multiplied by 8/27. In other words, you're doing 2/3 squared, so 2/3 times 2/3, and then times 2/3 again. Okay, so I'm going to say the volume, the question describe the effect on the volume. I'm going to say the volume is multiplied by I'll say 2/3 cubed, which equals 8/27. That's what changed. That's how the volume was changed. By multiplying the radius by 2/3 and by multiplying the height by 2/3, that's the change that happens. The volume is multiplied by 2/3 cubed, which is 8/27, which you can see right there. Okay. All right, so I'm having a little bit of technical difficulties here with this video, so sorry about that. Some of this, the recording kind of stopped, so I may be repeating myself in case some of it did not go through. But the next shape we have is a pyramid, okay, a pyramid. So this is not to be confused with the prism, because if you look at a pyramid, it comes to a point, okay? See how that pyramid comes to a point? That's how you know it's a pyramid, okay? And here's the formula. Volume equals 1/3 times the area of the base times the height. Volume equals 1/3 times the area of the base times the height. Depends on what shape the base is. So here we go. Travis is making a plaster model of the food guide pyramid for a class presentation. The model is a square pyramid, okay, so the base is a square, with a base edge of 12 inches and a height of 15 inches. Find the volume of the plaster needed to make the model. So, like I said, I'm having technical difficulties here with this video. So I already started doing the problem out. I don't know if it got recorded, so I'm just going to re-talk about it. Here's the formula. 1/3 times the area of the base times the height. The base is a square, so it's 12 times 12. Times 1/3 times 15. 15 is the height of the entire pyramid. So 12 times 12 is 144 times 15, 2160, divided by 3. The answer is 720. (720 inches cubed). Okay. All right, so that one was actually not that bad because you were given the actual height of 15. Look at this next diagram, okay? And let me get a colored pencil out so I can try to add a little bit of color to this diagram. Hopefully you can see it. Let me get a dark color out. Okay, this 15 is not the height. Okay, it's not perpendicular. Okay, that 15 is called the slant height. Okay, the slant height. It goes from the vertex along a face. Okay, that's the slant height. It's not the actual height. The actual height is this purple segment right there that I'm coloring in. Hopefully you can see it. You can probably see that in the video. This is the actual height right there. Okay, the 15 is not the height. That's the slant height. Okay. So what I'm going to do, I'll do this off to the side. Let me try to redraw this triangle so we can actually find the height. Okay, so let me try to take that triangle and let me redraw it over here. Okay. I'll just use X for now. I'll just use X. Okay. The 15, the slant height, that's the hypotenuse. And the question is, what is this side down there? Well, this is actually half of this side. Okay. Let me add a little more color so you can see a little better. I know this is hard to see. I'll use orange. Okay. The orange, that's half of 18. Okay. So this is going to be 9. Now let's solve for x using the Pythagorean theorem. X squared plus 9 squared equals 15 squared. So x squared plus 81 equals 225. Subtract 81. X squared equals 144. X equals 12 because you only want the positive square root. Okay. So that x represents the actual height of the entire pyramid. Okay. So that x is the height of the entire pyramid. So now I'm going to go into the formula for the volume of the pyramid. Volume equals 1/3 times area of the base times the height. The base is a rectangle, so I'm going to do 24 times 18. Times the height of the entire pyramid, which we just established was 12. Okay, so now you can do out the math. 24 times 18 times 12 divided by 3. That's a big number. 1,728 inches cubed. So that one was tough because you had to actually find the height yourself using the Pythagorean theorem. Okay, so we've done prisms, we've done cylinders, we've done pyramids. So 3 down, 2 left. The next one is going to be cones. Okay. So here's a picture of a cone. Notice how it comes to a point and it has a circular base. Okay. So the formula is volume equals 1/3 times base times height. And since the base is always a circle, you can just do 1/3 times pi times radius squared times height. Okay. Okay, so this one is actually going to be a hard one. Find the volume of the cone below in terms of pi and as a decimal. So we have a 45, 45, 90 triangle. (45, 45, 90). The leg equals the hypotenuse divided by square root of 2. Okay. Remember, this is 45, 45, 45, 90. So the leg equals 10 divided by the square root of 2. Now, we should rationalize that right now. Let's just do it right now to make it easier. Let's multiply by square root of 2 over square root of 2 to get 10 square root of 2 over 2. Let's make that 5 square root of 2. So that represents both the height and the radius because it's the 45, 45, 90 triangle. So the height and the radius are both the same. Okay, so here we go. Formula time. Volume equals 1/3 times area of the base times the height. Or you can do 1/3 times pi times radius squared. Okay. So the base is a circle. So 1/3 times pi times the radius, which is 5 square root of 2, squared, times the height, which is also 5 square root of 2. Let's take care of this. 5 square root of 2 times 5 square root of 2. That might be a little confusing. Do it on a piece of paper over here. Well, 5 times 5 is 25. And square root of 2 times square root of 2 is 2. It equals 50. Okay? So I'm going to say volume equals 1/3 times pi times 50 times 5 square root of 2. This question said give your answer in terms of pi and as a decimal. So what we're going to do is we're going to multiply everything but the pi. Okay? So we're going to do 1/3 times 50 times 5 times square root of 2. It's going to give you about 117. I'll say 0.9 pi. And it said as a decimal, so let's multiply that out. You should get about 370.2. Inches cubed. Again, when I did this multiplication out, I did out the entire decimal. I did not just stop at 117.9. I listed the entire decimal times pi, and that's how I got exactly 370.2 when I rounded it. If you round before multiplying by pi, you may be off by like a tenth or two. Okay. 2 more problems. Example 8 and example 9. Again, we do not have the height, we have the slant height. So let me draw a triangle off to the side. I'll use X for now. This is 16. This is 34. The slant height. Let's solve for the real height using the Pythagorean theorem. X squared plus 16 squared equals 34 squared. 16 squared is 256. And then 34 squared is 1,156. Probably know the answer right away. That's going to be x squared equals 900 when you subtract them, which gives you x equals 30. So that's the actual height. So now when I go into the formula for the volume of a cone, it's 1/3 times the area of the base times the height. The base is a circle, so it'll be 1/3 times pi times the radius, which is 16 squared, times the height, which we just established was 30. And again, this question asked for the answer 2 ways. It said in terms of pi and then as a decimal. So 16 times 6, multiply everything but the pi. 16 times 16 times 30 times a third will give you 2,560 pi. Multiply that out, you get 8,042.5. It asks for the answer 2 ways, so let's give it both ways. Okay, so we've done prisms, we've done cylinders, we've done pyramids, we've done cones, 4 down, 1 left, and the last one I think is the easiest one, the volume of a sphere. Okay, so there's the formula, the volume of a sphere. I think this is the easiest formula. Volume equals 4/3 times pi times radius cubed. Find the volume of the sphere below in terms of pi and as a decimal rounded to the nearest tenth. So here's my formula. Okay, so there's the formula, 4/3 times pi times radius cubed. And this time you're given the radius. Sometimes you may be given the diameter, so just watch out for that. This time we are given the radius. So we're going to do 4/3 times pi times 8 cubed. This question asks for your answer in terms of pi and as a decimal. So let's do 8 times 8 times 8 times 4 divided by 3. So I'm going to round it. That gives you approximately 682. I'll do 0.7 pi. Now, to make your answer better, I'm not going to do that times pi. I'm going to do this number times pi. Okay, because let me show you one more time. 8 cubed times 4/3. I'm just going to do that entire decimal times pi to get a more exact answer. 2,144.7. Centimeters cubed. Okay. 2,144.7 centimeters cubed. And that's the end of that lesson. It was a lot. We did the volume of 5 figures: prisms, cylinders, pyramids, cones, and spheres.